last leg of our wonderful 4-hour and 15-minute journey together. I'm going to teach you about lenses. We're going to learn about converging lenses and diverging lenses. We're going to learn how to do array drawings of converging and diverging lenses. We're going to learn how to have two lenses in combination with each other and how to deal with that. And then I think that'll be about it. Then you get to chapter 27, but I don't think we'll get to chapter 27. Just 1 second. Yeah, then we'll get to chapter 27, which I'm going to do dispersion of light and a bunch of other stuff. Okay, great. So here we go, lenses. A mirror is not the only thing I can use to have an object and then to create an image. We can also use a lens. Let me show you. Here's my object. Here's my mirror to create the image. Please notice the real image is on that side. The real image is on the same side of the mirror as the object is. See how it goes mirror, object, image. That's what happens when you get a real image with a mirror. Mirror, object, image. I can get an image with a lens. This is a lens. You see this thing, a lens? But in this case, to get a real image, do you see how it's kind of reversed? Now, instead of mirror, object, image, it's object, lens, image. The object is on one side of the lens, and the image is on the other side of the lens. So that's a difference between mirrors and lenses. But it turns out mathematically, mirrors and lenses are identical to each other. You'll use the same equation. I mean, heck, that's why they're called the lens maker's equation, not the mirror maker's equation. So you'll use the same equations and even think of things the same way. It's just a little bit different because to get a real image, the object is on the other side of the lens as the image. So let's go ahead and talk about how these lenses work. Imagine we have a converging lens. A converging mirror is a concave mirror. A converging lens is a convex lens. So mirrors and lenses are opposite. Convex mirrors are diverging mirrors. Convex lenses are converging lens. Let me show you how a converging lens works. You've got parallel lines hitting the lens. Parallel rays, rather, hitting the lens. Here's the tangent line to the lens. So here's the normal to the lens. My ray, if I was going from air to air, my ray would just go straight through. It would continue on horizontally. But I'm not going from air to air. I'm going from air to glass. Tell me, this blue ray, should it refract towards the normal or away from the normal?
Away.
I'm hoping you remember that when you go from a low index of refraction medium to a high index of refraction medium, that is a fast medium to a slow medium, you refract towards the normal. So this light ray is going to refract towards the normal. Consider this surface now. This surface, the tangent line is looking like this, which means the normal line is going to be perpendicular to the tangent line. If I was going from glass to glass, then this blue ray would just continue on straight. But I'm not going from glass to glass. I'm going from glass to air. And I haven't written it on the board, but I hope, are you guys okay with my assumption that this is air, but my lens is glass? As lenses tend to be, or glasses and things like that, glasses. Tell me, this ray, because I'm going from glass into air, I'm going from a big index of refraction medium and refracting into a low index of refraction medium. Does my ray refract away from the normal or towards the normal? Away. Yeah, away now. So do you see, at both boundaries, my ray refracted downward here. And I'm not going to go through the awful details, but the same thing would happen with this ray, only it wouldn't be as extreme, because here the normal line is at a real big angle. Here the normal line is almost horizontal. So you'd go like, and then this guy would be, and then this guy would be, right? But all of these rays would pass through the same point, the focus. So I want you to see that a lens, a convex lens, does the same thing that a concave mirror does. It takes parallel rays and bends them so that they all converge onto a focus. But whereas a mirror uses reflection to bend the waves, what does the lens use? Yeah, refraction. So on your Talon thing, we're now on chapter 26. Go ahead, at number 10. Look at number 10. While a spherical mirror uses reflection to bend and focus light, what do lenses use? Refraction. So please write refraction. This is your convex lens. The convex lens is a converging lens. How about the concave lens? What if I have a lens like this? This is a concave lens. Well, let's see what it does to the parallel rays of light now. Okay. Here's my parallel rays of light. Here's my normal line. Tell me, is that ray going to refract towards or away from the normal line? Yeah, away, because I'm going from air into glass. Small index of refraction medium into a big index of refraction medium. So this ray is going to refract away. And do you see how that's different from a converging lens? This lens, and I'm not going to go through the awful details again, but for the same reason there, you end up getting more refraction away. So you get this sort of phenomenon where the rays are diverging. The lens refracts the rays so that they diverge. So if somebody was looking at all these diverging rays, what would he have to do with those rays to figure out where the image is? Yeah, backtrack, track backwards. So you would go back like this, and go like this, and go like this, and go like this, and now you've got your focus right there. But tell me, what kind of image am I getting here? Yeah, virtual image, because these aren't real light rays coming together to make that image. Whereas here, I'm getting a real image, real light rays coming together to make that image. So yeah, the concave lens is a diverging lens. It makes parallel light rays diverge. But you can still see an image. It's just you've got to work backwards. One thing I want to make clear about lenses, wherever the object is, your eye is on the other side of the lens. Your eye is on the other side of the lens. So, you're not used to this, but I'll try to show it anyway. here's my object, okay? I'm gonna choose a